It may take almost half a year to develop fully functional software because modern business processes prefer custom software solutions. It means development cycle and testing methods keep changing all the time. But one question remains: what exactly goes into making comprehensive software? A software development cycle goes through some standard phases during the entire production cycle. In this video, you'll learn some easy steps that go into software development cycles. Not all of them though, because some life cycles may be a little different. Anyhow, following these steps will help you develop quality software with proper testing and deployment. So let's get started. But first, why are software development life cycles so important? Software development life cycle, I'll call it SDLC, is very handy when you're developing business solutions. Why? Businesses want scalable, flexible, easy to implement solutions. This means there will be a lot of trials and errors, and of course, a constant need for upgrades. It can be a daunting task to develop any software as a developer, but if you follow these SDLC steps, the job becomes much more manageable. But wait, don't you want to know the reason? With SDLC, it's easy to streamline process of software development. As a developer, SDLC will help you set goals and clearly define roles to perform different tasks. So your project automatically has a better flow and there are fewer errors. In short, it's a better organization of processes that may be haphazard without an SDLC. First, let's talk about the steps of a software development lifecycle. A software development lifecycle has the including steps: problem analysis and planning, software requirements and specifications, designing software outline, development of the software code, integration and testing, software implementation, and finally software maintenance. Step 1, analyze the problem and plan solutions. Software solutions must be easy and direct, which is why a company decides to go for these solutions. So problem analysis is the most critical phase and requires 110% attention to detail. When you are fully aware of the nature of the problem and the possibilities of any future setbacks, you are now ready to shape your ideas according to the situation. It's great to throw out as many ideas as possible, and eventually you'll find one that might work. You might want to know how. For any idea to work, carefully analyze the dynamics around it, and you must focus on defining ways for implementation of your solution and aligning your software solution with strategic objectives of the business and making sure that your requirement resources are available, analyzing the project cost, and figuring out how much time you need to complete the project. These dynamics will help you set short-term goals so that you can create tasks and milestones. That means that you can allocate time and budgets for each job and use your workforce accordingly. Now let's move on to the next step. Step number 2, requirement feasibility and software specifications. When you narrow down to a specific solution, you'll need to add more details to the project. This is where you'll gauge the feasibility of your project and potential solutions. A feasibility study gives you an idea whether you can achieve your desired goals or you are too ambitious. Feasibility analysis is a detailed process that requires input from other developers. So it's time to sit down with your team to get a clearer view of your project and get a deeper understanding of your goal. A feasibility analysis takes care of your project's technical and economic aspects and has a direct impact on the development cycle. Every task or milestone that you decide will affect the time and resources for your project, which means you can also calculate the efficiency of your solution. With a comprehensive analysis in your hand, you can set your software specifications more accurately. Consequently, there is low risk, and it's easier to make a backup strategy. If your requirement analysis gives you well-defined software specifications, you'll find it easier to implement in the next steps in the software development lifecycle. Next, step 3, designing the software. As you reach step 3, it's time to start shaping your idea into a workable object. Here you create the concept of your solution and design the structure of your software. The structure must be robust and meet all the specifications and requirements mentioned in step 2. A software design can be a visual model of your solution. It takes care of the functionality, defining tools such as hardware and software required to develop the software further. In effect, it's a structure that will support the future development of the project. As a software engineer, you should have clear understanding of the software design because it will help you design a more robust solution. Another critical aspect of the design phase is customer feedback. Make sure that your client can see the software structure. So if you can present solutions in the design phase, you can easily make changes in the development cycle whenever needed. Step number 4, coding development. As you set up the software design, you're ready to code. Coding is all about turning your design into a workable solution. Coding tends to be the most fun phase in the SDLC and requires 2 things: resilience with the ability to iterate solutions and immense attention to detail. As a software developer, you'll be coding for hours and hours without realizing how much time you've spent in front of your screen. Your code must answer all the questions and requirements from the previous phases, which means that you'll rely heavily on your previous work. Once the code is complete, it's ready to enter the new software release cycle. Now it's time to start testing. Step 5, we have integrating and testing. As you start testing the software, you'll understand the shortfalls and possible glitches in your design or code. This is the time you'll start integrating software to understand what needs to be corrected. More importantly, there are various types of tests to include, such as unit testing, system integration testing, end-to-end testing, functional testing, performance testing, user acceptance testing, and smoke testing. As your software goes through a series of thorough tests, you'll quickly understand the corrective measures you might need in the future. If you have a comprehensive testing mechanism, your software product will be more robust. Software validators use different frameworks to make sure everything is on point and can ensure the team can produce clean code and validate the critical aspects of the software. As a result, your software will mitigate software bugs and will be more robust. Step 6, deploy your code. After successful testing, your software is ready for deployment. The deployment step contains several steps before your software solution is entirely out there for the users. First, your software will go into production. Depending on the complexity of the software, it might be a straightforward release or a staggered release. Deployment is the final step in software production, and your software is now ready for the end users. Step 7, maintenance. Once your software is out there for end users, you'll need to perform regular checks and send software updates to the users. This way, your software won't become outdated. This is critical, especially in the modern age, because operating systems and firmware keep changing rapidly. This is why there is a constant need to upgrade and make sure your software is more robust. Regular maintenance also helps you polish your software and fine-tune different parameters to enhance the user experience. As you receive customer feedback and performance results, you can develop customer-oriented product, adding new functionalities according to the user requirements. I hope this video helps streamline things for you in your next software development project. Stick to them and you'll eventually minimize errors and become more efficient. If you like this video, do subscribe and check out my video on my lessons learned from 9 years of developing software. See you in the next one.